Thank you. Thanks. Bless you all for staying till the very end. I know it's quite tiring by the end of it. And also thank you to all the volunteers for another lovely Pydata conference. I first came here in 2016. I've not been to every one, but it's always been really nice. And you know, it's the first time I'm speaking, so it's about time, isn't it? No ropes on a boat. Part one. There are no ropes on a boat. This is a photo I took. I used to sail in a racing crew, which I can recommend. It's a lot of fun, especially if you don't have to pay for the boat, which I didn't. The person who owned this boat used to say to me that, you know, if I liked the idea of having a boat, I could replicate the experience by standing in a cold shower and ripping up £20 notes. Especially this is on the North Sea as well. You know, it's not very often great weather. And this is this is something I took when I was on the boat. Being you know, I was the most inexperienced sailor on the boat, and I would sometimes ask for a rope. And you know, when you're in a race, it's a very intense situation. Lots of shouting going on. The boat's probably like that. Probably about to crash into somebody. And if I naively just shouted that I needed a particular rope passed to me or that I was doing something with a rope, I would get yelled at. There are no ropes on a boat. And what that means is as soon as a rope gets onto a boat, it has a specific purpose. And so it is given a certain name. So once you're on a boat, there are halyards, warps, sheets, lines. Nothing is called a rope except the bell rope. And so you have to be specific, and it's quite clear why that is, right? It's a very intense situation. Everything is a rope, so you can't call it a rope. You have to be specific about what you want. Otherwise, you will get yelled at. And I was reminded of this when I was talking with my team, and one of the things we look after is forecasting at Spotify. So we try to coordinate all of the forecast models that we have to try and predict what's happening in our sort of complex part of the world. And I had to say to my team, can we just ban the use of the word forecast in this room, because I never know what we're speaking about and we need to be more precise. And it just reminded me back to being shouted at on a boat. So maybe it'll be a bit clearer if I explain what the overloaded terminology is. So firstly, there are lots of things we are forecasting, some of which I've put up here. So we're forecasting, you know, costs, revenues, subscribers, users, prices, streams, ad impressions, bid densities for ads, foreign exchange rates for all the market. We're in 184 markets, so there are a lot of different things that we're trying to forecast, and then we're trying to forecast it in lots of different contexts for the decisions that need to be made. So they might be it might be targets for sales. It might be projections, short-term projections that someone wants to make. It might be a what-if scenario. It might be a ML baseline. It might be something that a domain expert has added a layer of human judgment onto. It might be the guidance that we're sending out to investors. It might be all of these things. And then given that context, well, you might need a forecast at a different level of granularity, a different cadence, a different horizon, like how far forward are you looking, precision and origin. And then if we look at granularity, it's, do you need this forecast at the global level, or do you need it by market, or do you need it broken out by product or by cohort? We have, you know, I know there's I think there's just free and premium users of Spotify, but there's actually 11 dimensions we use to categorize cohorts, so it explodes very quickly. And we're calling all of this the forecast. And it gets very confusing if we do that, because it's just all a big muddle of forecast. So what breaks when we do this? And this is kind of the point I want to get to, really. It's not just the problem of me getting annoyed about overloaded terminology, which, you know, is a problem, but it's not just semantics. It's actually like you realize a result. It's a symptom of the failure and coordination of structure if you don't have things laid out in a coherent way. So it's actually, when this confusion arises, you want to look at it and say, how should we be structuring all of this information so that it is well coordinated, so that we are referring to the right things when we need to, and so that we're all going in the same direction. And so, like some concrete cases you get of this is you have someone from the business who's taken a model output and they're building on top of it, but it was actually someone has adjusted the configuration because it was a what-if scenario, and they just changed some prices, but that's not the prices that we're going to be using, and they've taken that wrong assumption and used it. That's a big failure that can happen. Or you can have somebody overwriting the assumptions that go into a model, and if you don't have versioning as a concept, then you are going to overwrite and lose some of the previous information, and especially when it comes down to things like auditing and financial controls in the US, these things have to be very, very precise. So it is important that we try and think about this structure and get it right. Part 2, the sea of forking paths. So this is where I'm going to try and describe to you what we think this structure should be that we need to sort of tease out to remove the confusion. And I'm going to start with, the thing that we've seen a million times, we're all very familiar with, which is a workflow for an ML run, in this case a forecast, where we're tuning a model, training a model, we're going to make predictions on it. It's important for us that we have the ability for people to make adjustments to those baselines where they have particular domain expertise. Evaluate them, which obviously feeds back into the tuning loop, and then make reports. That doesn't exist sort of as a single thing. It's each forecast that you produce is actually a point in this high dimensional space. And obviously I only have 2 dimensions on a slide, so I've tried to draw it with these columns, but as an example, so you've got the origin. Where did you start with this forecast? Is it an F1 from the 1st of January? Did you do it a month later, or is it just an arbitrary, on this date I wanted to do this forecast? Are you looking the horizon? Are you looking 7 days ahead through to long-term 5-year forecasts that we actually have to make, even though they're just projections? Do you need it daily, monthly, quarterly? What precision do you need it at? What granularity? And then over kind of all of this is like, what are you using the information for? What decision does it help you make? Is it a target that people are aiming for? Is it the guidance that we're giving out? Is it like an internal what-if scenario analysis? And then each forecast then we can think of as a point in this space, or in this drawing like a line. So you might have one forecast there which is a quarterly guidance for the F1, and that sits there in this space, right? And then you've got this blue one which might just be an ad hoc scenario. You wanted to see what's happening over the next 7 days. So I'm going to try and bring that into the same picture. Obviously that was like, I'm telling you it's multidimensional, but I'm going to add it as one dimension into this plot by going back into the sliders versions. And so I'm just drawing it as a line there. But what you actually want is this to be a graph, right? You want to be able to take someone else's plans and assumptions and say, okay, I want to take this one, I want to fork it, I want to make my changes to it, save those, have a new version, tag it, this is my forecast for this, and maybe some of them where they're like, the quarterly or monthly forecasts, we want to have them as releases so everyone knows this is the primary one that's going out. So we've got one graph going that way, and then at the same time, each of these models is connected to others. So there is actually a model graph which exists, because this whole thing, this is what we're trying to do, make sure it's all coherent. So if I just take one of them, this is just a small bit of the graph, by the way. But if you take the ads demand, which is a forecast of like how many ad impressions do we think we will sell? Well, that is capped by the number of available impressions, which is the inventory there. how many slots appear for people to listen to an ad. And that's dependent on how much listening people are doing on the free tier of Spotify or listening to podcasts. You know, these things connect into each other. So you want one to drive into the next, and you want to keep it all coherent so that if someone has changed the assumptions upstream, those same ones come downstream. You know, and the demand goes into the revenue, and then the revenue indicates how many royalties we pay out, and together they go into the, you know, in the end, the CFO wants to know what is the gross margin we're going to get if we make these decisions. We think it's this, or the unit economics model. So we have graphs on graphs on graphs, graphs all the way down. So you have this, I've tried to add that in again. So this is the top to bottom is now the upstream downstream graph. So this thing in the middle might be the demand model, and then upstream of that you've got the inventory and the other models, and downstream you've got the revenue model. And so we want to kind of build up this structure of a thing which maintains everything in an auditable way, and so that everyone knows exactly what they're looking at. Part 3, the rigging. I started stretching this nautical theme way too far. I had to dial it back, so this is the last one of those, I promise. But this section I think is probably the most interesting for people here, because I want to talk a little bit about how we, you know, implement that. And as you might imagine, because I'm here, that we do a lot of it in Python, right? So if we go back from part 1, I was trying to express the idea that we have all of this structure that we were kind of not expressing properly, calling it one thing. And so then we thought about what the representation should be of it, what the structure should be, sorry. And now we're going to think about what is the code representation implementation which gets us to having this structure. And so we have this product called One Model in Spotify, which is the thing that tries to do all of this that we just talked about, bring everything together so that it's all coherent and so people know where they're at with everything. And I just thought I'd list some of the, you know, these are the primary components which go into it. And you will note as well, that I'm not talking about the actual modeling algorithms here. And I've heard lots of really good talks at Pydata and Pydata London on different types of algorithms, approaches. And I'm sort of deliberately here trying to focus on this idea of coordination, because the idea I have is that coordinating your forecasts is as important as having accurate forecasts, because if you have people, and not kicking over your drink, sorry about that. So yeah, you need it all coordinated. So, but I will mention modeling in a second. But yeah, so we use BigQuery. BigQuery we use all over Spotify, but in this case, we use it for storing the inputs and the outputs of each model. And the important thing here is that we store everything. So it's version by run. You can look up any input and output, and you can reconstruct any historical forecast whenever you need to, which we do need to. We have auditors come in and say, you know, you gave this particular guidance at this time. Show us the history and how you got to those numbers. Python, first, obviously. So that's what we use for the model logic, pipeline definitions, and typing the schemas. So there is a solid contract from each model to another, so they know what is coming in and what is coming out. And then Flight is what we use to hold it all together. So Flight is an orchestration tool that was built primarily at Lyft, but also Spotify contributed quite a bit to it. And it's become our internal orchestration tool we use everywhere. And we use it, you know, not just for the orchestration and caching and scheduling, but one important thing is caching, which means that in that graph of the models, when you change something in the middle, only the downstream models will need changing. So the upstream models, if nothing's changed in them, they don't need to be updated. And that means you can run things much quicker because the whole thing doesn't have to run each time. You just run what needs to be run. It takes care of the parallelism in many cases and logs all the execution, so we get that full lineage that we need for auditability. And this is the sort of thing which gets us to, you know, being now able to do lots and lots of scenarios, which is what happens now. Forecasting Hub is a web UI, which is what most of the users use to do this, making changes, saving changes, looking at diffs, and it's a very intuitive interface so that they don't necessarily need to see any of the flight or underlying. It's just, I wanted to make these changes, I'm going to save them. I want to clone this workspace into this one, so I've got a new forecast space. And then actually when they want to edit some of the assumptions, what it does is pop out Google Sheets for them to edit and then close, and it just gets saved. So they don't see the data frames or anything. They're very used to seeing spreadsheets, so it pops up the Google Sheet, and we use the Google Sheet API to just pass that back. They don't need to save anything, it just gets saved. And so this is the thing that kind of ties it all together, primarily the flight in the middle. So each execution in flight gets a version ID, and we just hook onto that to connect everything up and make sure everything stays together. I said I would mention modeling, and part of what MoModel does is it doesn't matter what kind of algorithm you use to do your modeling, as long as it's got the standard kind of, fit predict APIs. And we have some models which are just rule-based, we need this to be this plus this. And some that are just statistical models all the way through to more complicated ones. But some of the things we need in the best case are we need this parallel scale, because even for one metric, we might have tens of thousands of time series that are being forecast at the same time. When you do the market, product, cohort, grid, for like the royalties model, we are forecasting what every licenser and publisher will be paid out. So and there's a lot of those in the world. So it needs to scale well in parallel. Obviously, for this DAG connection to work well, you want to have a system that includes exogenous regressors. So that's the thing where you're taking the output of one model, and at the predict step, passing that in to the downstream model to make a prediction based on the upstream change that you just asked for. Probabilistic prediction, we need uncertainty a lot of the time, and then reconciled hierarchy. So if you want to predict at the global and at the region and the country level, and make sure they're all coherent, either as a top-down or a bottom-up, or something like an optimized, minimized trace optimization. And so many of you might have heard of or used Nixtler, and I really like that because it gives me all of these things. So for the newer models that we're sticking into one model, if we're changing a model, typically move it into the Nixtler API, because you can use all kinds of different algorithms that you want, but the API is the same and you get these features that we need. Just a little bit on the structure in there, so so you can see what it kind of looks like. You'll have a forecast object which has a schema. It will have a date time. It will have some granularity and some values, and it's coordinated through the version ID, so that gets passed in then, and that's what the ads revenue model is expecting from the ads demand model. The schemas are kind of the contract from one to the next. And then, just this idea I explained, that because of the versioning, you don't need to rerun nodes that haven't changed. So if you change the sell-through here, you don't need to rerun the content hours model. It's stayed the same. And so you just move into the ones that need to be redone. And then in terms of the impact we've had on this, I mean, when Spotify first had its IPO and became a public company, and all of this had to be a lot more controlled, it was a huge process. There were many people, coming up with a forecast, outputting that to a spreadsheet, sending it to another analyst who's then doing their forecast based on this one. And then they find out that the change has happened upstream and that they've got one that is out of date. No one has got anything which is coordinated anymore. And it was a huge process. It would take just a ridiculous time of the quarter. And now I just changed this because previously when this has been shared externally, I think we said less than 2 weeks, but it takes a couple of days now for them to do that quarterly forecast at the end once they've got everything up to date with their assumptions. And it also gets us to the point where instead of like this huge process to get one quarterly forecast out, we can now run it all the time. So people go in, what happens if we change these assumptions, these prices? What happens if this happens to foreign exchange rates in these countries? What is the output going to be? And so we use it all the time. And we have a lot of models in there now, about 20. And that, that sort of made it, rather than this one-off quarterly thing, it's like more of a tool for scenario analysis that gets used all the time. We aren't the only company who's done things like this, and we've built on seeing what other companies have done and written about. You can read blog posts that Uber have written about, and Lyft, and I'm sure plenty of other companies have dealt with the same thing. So I'd say if you've come across something like that, always happy to hear what people are doing in this space and learn. And also, if you want to talk to me about it, please do. That's it, I think. No ropes on a boat and no forecasts in my Google Meet, please. Thank you.